Good evening, professors, researchers.
Yes. Good evening, Kumudha ma'am. You can start.
First of all, I'm really sorry for each one of you for making to wait.
Sir, good evening, sir.
Yeah.
Good evening,
Kumudha
madam.
ma'am, you can start, ma'am.
Yes, sir, sure, sir. Good evening, one and all. I'm Kumuda, Assistant Professor from the Department of Social Work, CMS College of Science and Commerce. I'm overwhelmed to welcome Dr. Ambati Nageshwara Rao, resource person of this session, Dr. Bennett and his team, and other participants to this 2 weeks International Methodology Workshop. I also take this opportunity to brief about our 37-year-old college in Coimbatore. Team of 48 eminent personalities, leading businessmen, and accomplished professionals started CMS Educational and Charitable Trust, a distinguished non-profit organization which has evolved into a premier educational entity known for excellence, integrity, and community service. Under the leadership of visionary educators and administrators, CMS has grown into a reputed group of institutions committed to deliver high quality, affordable, and holistic education. CMS College of Science and Commerce, which was an autonomous affiliated to Bardhan University College, re-accredited with A double plus grade with CGPA 3.38. This college was established in the year 1988 with 26-acre campus. Our campuses, Wi-Fi enabled digital campus, well-equipped laboratories and research facilities are available. We are with modern libraries and digital resources, smart classrooms and seminar halls, sports and physical education facilities, hostels, cafeteria, transport facilities, and student support and placement cells. Our academic strengths include highly qualified faculty, interdisciplinary curriculum, research-driven environment, strong industry academic partnership, holistic student development initiatives, consistent placement record. We have MOUs with national and international organizations. Our college offers 29 UG courses, which includes BSc Mathematics, Computer Science, Microbiology, IT, Digital and Cyber Forensics, Biochemistry, Computer Technology, Physical Education, Electronics and Communication Systems, Psychology, Catering Science and Hotel Management, Food Science and Nutrition, Biotechnology, BCA, Artificial Intelligence and Machine Learning, Forensic Science and Data Science. We have Commerce stream, which has BCom, BCom CA, BCom PA, BCom A&F, and management courses like BBA, BBA CA, BBA Aviation Management, BBA Logistics, BA English, and BA Criminology. Along with this, we have 15 postgraduate programs, MSc in Mathematics, Computer Science, Microbiology, Biotechnology, Biochemistry, Applied Microbiology, Data Analytics, MCA, Applied Electronics, and IT. We have MCOM, MIB, MA English Literature, MSW, PG Diploma in Fitness and Education also. Our department, that is the social work department, was started in the year 2002 with 3 specializations: human resource management, medical and psychiatry, and community development. Our program integrates academic rigor with experiential learning, prepared skilled social work professionals capable of addressing complex social issues. Our department unique features include social lab, pre-employment training, theater skills training, rural and tribal camps, industrial visits, Swachh Bharat activities, extension programs, networking with the industry ambassadors, industry and institute forum. We are collaborating with leading institutions for internships, block placements, research, and fieldwork training. Our collaborators include NIMHANS Bangalore, IMHANS Calicut, Ekam Foundation Chennai, District AIDS Control Unit Coimbatore, Observation Home Coimbatore, Kasturiba Gandhi De-Addiction Center, Satula Trust Hospital Kerala, DCPU units, Central Prison Pujapura, Native Medical and Charitable Trust, Sahai, Trada, and many other NGOs, industries, hospitals, and rehabilitation centers. Our career opportunities include medical and psychiatric social workers, industrial social workers, HR managers, labor welfare officers, CSR specialists, counselors in schools and colleges, project coordinators, NGO administrators, and community development officers. Our students are placed in prestigious organizations such as NIMHANS Bangalore, Chaitanya Pune, Kerala Institute of Medical Sciences, Kitex Cochin, EXL Cochin, Childline, Hamilton Plaza Nursing Home USA, Mercurius IT Bangalore, Social Welfare Department Agartala. Apart from our college, we have sister concerns which include CMS College of Engineering and Technology, which was established in the year 2009, approved by AICT New Delhi and affiliated to Anna University. This institution is offering engineering programs with industry-oriented curricula. We also have CMS Institute of Management Science, which is a B school, a leading B school in South India, affiliated to Bardiyar University. It offers MBA program with 7 specializations. We also have Academy of Management and Technology, which is established in the year 2009 and approved by AICT and affiliated to Anna University. It offers programs integrating management and technology education. Our college has outreach and social commitment, which are doing through rural and urban outreach programs, health, education and livelihood initiatives, environmental sustainability drives, Swachh Bharat campaigns, social awareness programs, NGO partnership. To conclude, CMS Educational and Charitable Trust continues to be a benchmark in quality education by fostering academic excellence, character formation, innovation, and social responsibility. With world-class institutions and a commitment to community empowerment, CMS stands as a trusted name in shaping future leaders and contributing to societal progress. Thank you. Sir, session is over to you, sir.
Thank you, ma'am. Thank you so much. And I'm very happy to know about your institute and the kind of courses that you're offering on it.
Thank you, sir. Thank you.
I'm just sharing my screen. I hope my screen is visible to all of you. Yes. Is it visible, my screen? Shall I go ahead? Yes. Okay. Thank you. Thank you so much. Okay. Before starting the session, let me spend around 5 minutes. Coming to the day 2, that is, day 2 means as a part of yesterday's session, as a part of quantitative data analysis using SPSS. As a part of quantitative data analysis using SPSS. Yesterday, we have covered about, other than interface of SPSS, we have started talking about how to conduct the normality test, how to conduct the frequency tables, cross tabulations, charts, and we also discussed about certain data transformation techniques like recode, data computation, missing value treatments. Further, we also discussed about a comparison-based test, one sample t-test, independent sample t-test, and paid sample t-test. So this is what we have covered in the previous class, that is yesterday's session. As a part of today's session, For the first 1 hour, I'll be talking about one-way ANOVA test, then chi-square test. Within chi-square test, we have two types of test: chi-square test of independence, chi-square test of goodness of fit test. Second of session for the next after 1 hour. Second off, I'm going to talk about correlation, regression, and if time permits, structural equation modeling. So this is what we are going to have for the next 1 hour, 45 minutes, or in between, if you ask, if you want me to repeat any of the steps, please ensure that you'll stop me wherever is required. Don't wait. At least you can put the message so that we can go ahead with simultaneously. As it is a hands-on practice, I'll be more happy if you ask or if you want me to repeat any of the steps. Okay. So coming to the one-way ANOVA, it is almost, I can say that is equal to independent sample t-test. If you recollect what we have discussed as a part of independent sample t-test, as a part of independent sample t-test, we require two independent groups. Whereas when it comes to the ANOVA test, if you have more than two groups, like for example, yesterday, we were talking about gender and their height, right? Male, female. If you have two groups, that comes under independent sample t-test. But if you have more than two groups, whether it is a independent sample t-test, ANOVA test, basically you're trying to compare between groups. Now, the one of the main criteria for using ANOVA test is we should have more than two groups. It can be 4 groups, it can be 5 groups also, no problem. But more than 2 groups, if you have it, one has to go for one-way ANOVA test. Now, another important point, just like independent sample test, we require two variables. One dependent variable, one independent variable. Independent variable must be categorical data and dependent variable must be continuous data. So there is no change, just like independent sample test. Only thing is one independent group should be extra, like more than 2 groups should be there. That's what. Now it is also known as one factor ANOVA, one-way analysis of variance. Look at the data requirements. In order to conduct the one-way ANOVA test, we require independent variable that must be continuous data, that must be either interval or ratio, or it can be that is interval or ratio, that is a dependent variable. When it comes to the independent variable, it must be categorical data. It can be either nominal or it can be ordinal, but it should be more than 2 groups. Okay. And independence of observation, random sampling, normality distribution. Yesterday we have discussed about normality, how to conduct the normality test. In order to conduct the normality test, we have so many options are available, starting with Skinner's kurtosis, starting with the Sperry-Wilkie test. Then we have histogram, we have box plot, we have normal QQ plots. So there are so many options, but as a researcher, you can take one of the option. If you take normality test, that is Sperry-Wilkie value test, that is good enough. If you want to fill number of pages as a part of your PhD, in addition to one statistical measure, you can also take one plot, histogram or QQ plot. But as an examiner, we don't feel like to see, same thing you're putting in the 2 or 3 different formats, right? We want to know as a examiner, are you able to conduct normality test? Are you able to show us whether your data qualified enough to conduct parametric statistical test or not? That is the main objective of conducting normality test. Homogeneity of the variance test, yesterday also we discussed as a part of independent sample t-test, right? Means we are assuming that if there are more than 3 groups, we are assuming that all the groups have equal variance. What are the responses that we are getting? They are more or less same. There is a homogeneity of the variance. There should not be an outliers. So there is no single point that should be discussed as a part of ANOVA as on till this particular moment. Okay. It's just almost equal to independent sample t-test. Only one difference is that as a part of ANOVA test, we are going to have more than 2 groups. Now, next point. When it comes to the normality test, in addition to, for example, this is test of the ANOVA test. If you open my data set, if you open the data set that I have given to all, let me check. If you open the Google Drive, there is a file name ANOVA. In the Google Drive link, there is a file name ANOVA. I just want you to all download this particular file. I have shared ANOVA file. I have shared chi-square test as a part of today's session. And there is already file there with us, like a QDA using SPSS. It consists of correlation regression test. All statistical test data is available here. Today, I have updated two files today morning. One is ANOVA, second one is chi-square test. By the time I complete the theoretical part, the scholars, those who are practicing along with me, please ensure that you'll start downloading this data set, ANOVA and chi-square test. Okay. Now, as a part of ANOVA test, my hypothesis is all income groups of prisoners' happiness means are equal. All income groups of prisoners' happiness, all income groups of prisoners' happiness means are equal. I think let me open this. I'm opening the same file, that is Ambati Nageswar Rao. There is a file name. I'm just opening the same file. I'm not opening the ANOVA file. I'm opening the same file, that is QDA using SPSS. Now just look at the data as for the hypothesis that we have it. We are talking about happiness. All income groups of prisoners' happiness means are equal. Okay. Let me close it. Just I'm closing this. I'm just opening the ANOVA file, the file that I've shared. Just look at the data. I have two variables. Look at the data that I have given to all. I have two variables. One is performance of the leader. One is performance of the leader. Second one is sex role type. Let's try to understand the data that we have with us. As a researcher, I'm framing my hypothesis saying that the leader who says that their sexual orientation, like we have four types of sexual orientation. First one is sex role diffuse. The person who is not very strong masculine type, sex type. I'm repeating again. Sex role diffuse is nothing but the person who is not very strong, strong enough to say that they are masculine or feminine typed. The person who is not strongly associating himself or herself towards either masculine type or sex type. Second one is masculine sex type. Third one, feminine sex type. Fourth one is the person who is having strong feminine, strong masculine as well as feminine sex type. Okay. Now we have four categories of sexual orientation, and we are collecting the data from the from various companies, various organizations who are working as a leaders, and you want to see their performance based on the orientation, based on the question they're opting for it. So we have responses. Look at the data. Look at the data set. We have around 198 responses. We have it. We have 198 responses. This is completely the performance for out of 10. Out of 10, their performance marks we have it. Out of 10, out of 50. So we have the marks as a part of the performance. Whereas when it comes to the categorical data, we have more than two categories. How many categories we have? We have four categories. Sexual diffuse, masculine sex type, feminine sex type, androgenesis. Now the person who opt for masculine sex type, what kind of performance they have it? The person who opt for feminine sex type, what kind of performance they're having it. The person who is opting for androgenesis, I just want to know, depends on their sexual orientation, whose performance is good. That is the main objective of my hypothesis. So as a part of my hypothesis, I'm framing my hypothesis. I'm framing my hypothesis. All types of leaders, all types of leaders, all types of leaders means are equal. Look at the hypothesis. We have 4 types of employees, 4 types of leaders. All types of leaders performance means are equal. I'm saying that there is no significant difference between the performance of the leader on the basis of the gender, on the basis of, sorry, not gender, sexual orientation, like feminine types, masculine type, androgenesis type. Okay. Now, this is my null hypothesis. Whereas when it comes to the alternative hypothesis, I'm saying that one of the group performance is better than the rest of the groups. Like, for example, the income group of prisoners who are earning more than 25 lakhs rupees happiness is not equal to others. The person belongs to particular sexual orientation. As a researcher, you are coming some assumption, some kind of hypothesis. We have 4 types of categories. You can take any sex type, any sexual orientation type, or any type of category. Like, for example, I'm saying that sexual diffuse performance is lower or not equal to others. Performance is not equal to others. Means this particular sexual diffuse type employees performance is not equal to remaining 3 types of categories. If this is my hypothesis, looking at the data that we have 2 variables. One is categorical data. In that particular categorical data, we have more than 2 groups. So we are qualified enough to conduct the independent sampling test. Second one, we have dependent variable, that is continuous data. Okay, come to the next again. So we are able to fulfill criteria number 1. We have dependent variable, that is continuous data, that is nothing but leadership performance. Next one, we have independent variable, that must be categorical data. It must have more than 3 categories. It must have more than 2 categories. So we have sexual orientation. We have 4 categories. So we can able to conduct the ANOVA test. Now coming to this particular part as a part of the data, this is also as a part of data collection. This is also as a part of data collection. We are able to fulfill it. Now coming to point number 6, we don't know whether leadership performance, whether our data are distributed normally or not. But I believe that all of you knows how to conduct the normality test. I'll repeat once again for today because we have to conduct 5 more statistics. One time I'll repeat it for the beginning of the session. How to conduct the normality test. Then I'll also talk about what is homogeneity of the variance for the ANOVA test. Along with the normality test, we'll also see outliers. Now, in order to conduct the normality test, we are going to have again null hypothesis. Please remember this particular point once again here. Very important point. As a scholar, as a researcher, you're thinking that you are framing hypothesis one time. It's not that one time framing hypothesis. Sometimes for each statistical test, you have to frame 3 or 4 hypotheses. As a part of your research proposal, as a part of your research methodology, you are going to have one hypothesis for particular variables. Like, okay, like for example, in our case, our hypothesis this: all types of latest performance means are equal. That is as a part of my study object, study finding, okay, hypothesis. But in order to conduct the ANOVA test, the single hypothesis is as a part of research methodology, like alternative hypothesis, sorry, null hypothesis and alternative hypothesis. This is one. In addition to this particular hypothesis, depends on the data requirements that you are going to fulfill, like the kind of assumption that you're going to fulfill. You are required to test more than one more hypothesis. In this particular case, as a part of conducting normality test, we are going to have hypothesis, right? And in order to conduct the homogeneity of the variance, we are going to have hypothesis. Normality test, yesterday I have shown you how we are going to frame the hypothesis. As a part of null hypothesis, we are going to show that the data that we have collected are normally distributed, right? Similarly, as a part of homogeneity of the variance, we are going to have one more hypothesis. Let me show you what is the hypothesis of the homogeneity of the variance. To satisfy the assumption of homogeneity of the variance, we are looking for Levian's test to be non-significant. Means we are saying that as a part of our null hypothesis, all the groups are equal. All the groups are equal. As a part of alternative hypothesis, we are saying that all the groups are not equal. So in that case, our normality test value, our homogeneity of the test value should be non-significant. When it comes to any statistical test, if you want to say that there is a significant difference, as a researcher, we always expect that we should get our p-value should be less than 0.05 as a part of any statistical test. But when it comes to normality test or when it comes to the homogeneity of the test, we always look that our null hypothesis, that is our test value, significant value should be non-significant. Means we should always expect that our p-value should be greater than 0.05. If it is going to be greater than 0.05, it means equal variance assumed. Why is this? Because as a part of our null hypothesis, we are saying that all groups are equal. Means there is no significant difference between the groups. Okay. Now for that case, we always look for our p-value should be non-significant, especially for these 2 points: normality test, homogeneity test. Similarly, if you go into other advanced level statistics, like within regression, we have so many other statistics where for every concept in the regression test, name it ordinal logistic regression, binomial logistic regression, we are going to have so many other hypotheses like this. Actual hypothesis, this one, what we have. Actual hypothesis, this is the one. But as a part of the statistical test, you might be required to conduct few more hypotheses. And whatever you are going to conduct a few more hypotheses, we always look for that p-value should be non-significant. But for this particular hypothesis, we always look for our p-value should be less than 0.05. I hope I'm not confusing. Please let me know if there are any things that if I need to be clarified. Okay. Okay. Now come to the normality test. How to conduct the normality test? You need to go to analyze. We need to go to analyze, descriptive statistics. Right side of the descriptive statistics, we have option called explore. I'm not going to repeat normality test for the coming statistics. Those who not attended yesterday's session, please look at it, how to conduct the normality test. It is one of the important procedure. One should conduct it if you want to use parametric statistical test. Okay. Without conducting normality test, you cannot go ahead with, you can't decide whether to go for parametric, non-parametric. Okay. Please. So in order to conduct the normality test, go to analyze, descriptive statistics. If you look at the right side of the descriptive statistics, we have option called explore. The moment I click on the explore, I got the new window. And if you remember yesterday point, in order to conduct the normality test, we required only quantitative data. Means as a researcher, you can only conduct normality test only for continuous data, quantitative data. You can call it as a scale data. You can call it as a quantitative data. You can call it as a continuous data. You can call it as a metric data. People call with 4 different names. Okay. So in this particular case, we have 2 variables, but which one is a quantitative data? Leadership performance. Leadership performance is the quantitative data. Go to statistics. I want to see the descriptives. I also wanted to see whether are there any outliers. I also want to see whether are there any outliers. Click on continue. In addition to the statistical test, I also wanted to see the plots. I also wanted to histogram. Okay. I wanted to see normality plot like a QQ plot. We have a box plot. Similarly, I also wanted to histogram. Okay. Click on both. Okay. Now just come to the normality test result. Our p-value is less than 0.05. I just want help from someone. I just want to understand, looking at the p-value, whether are we able to fulfill the assumption of normality distribution or not. Any volunteers, please put your message. Whether are we able to fulfill the assumption of normality looking at the p-value. Any volunteers, please put the message. Whether our data distributed normally or not. Yes, no. Okay. There is only one person. What about others? Okay. So here our p-value is less than 0.05. Our p-value less than 0.05. I'm repeating again. As a part of our normality test, our value should be greater than 0.05. Then only we can say that our data distributed normally. I request, if it possible, please note down. These are the very important point to this one. Normality test value should be, p-value should be greater than 0.05. But in this particular case, our normality value is less than 0.05. Actually, we cannot go ahead with conducting ANOVA test for this particular data. Why? Because our p-value is less than 0.05. It means the data that we collected is not normally distributed. So if you feel, okay, statistically showing some, our value is not normally distributed. Let me look at the histogram. Are we getting bell-shaped curve? No. It's not exactly bell-shaped curve. You can see that right side tail is very long tail. It is a very, we didn't get the bell-shaped curve here. So there is a problem with the normality of the data. And you can see that there are certain data is deviant from this clustered line, this particular diagonal line. Okay. Let me look at the box plot. It is not showing any deviant. Overall, our data is not distributed normally. So we can't supposed to be conduct this ANOVA test with this data, but we'll going ahead as a part of the class. We are going ahead. You need to decide whether this particular value is allowing you to conduct the ANOVA test or not. Okay. Now, in order to conduct the ANOVA test, go to analyze, compare means, go to analyze, compare means. Right side of the compare means we have option called one-way ANOVA. One-way ANOVA. Just open it. One-way ANOVA. Now, our dependent variable is leadership performance. Six-role type is factor. That is the categorical data. We have 4 types of categories we have it. Now, there are a couple of options here. Go to contrast. Here, nothing to do here. There is one more option. There is one more statistical test as a part of ANOVA test. Now, there are more than 3 groups, more than 2 groups we have it. ANOVA test is going to help us to understand whether there is any significant difference between groups. Like we have sexual diffuse, masculine sex type, feminine sex type, androgenesis. We are only able to understand whether there is any significance. In addition to significant value, yesterday I also mentioned about effect size. As you can see that we are also going to calculate how much effect size we have, like percentage. Like, okay, if you're having less than 0.02, it comes under 55% effect size. If it is coming under 0.5, it is going to have around 65% effect size. It is only saying that this much percent significance. One value, one variable and the other variable. But here, I also wanted to get additional information. If you don't take it other way, we have assistant professors, associate professors, professors, senior professors. Okay. I'm looking at how assistant professors are performing better than associate professors, or professors are performing better than assistant professors. If I simply say that professors are performing better than assistant professors, there is a significant difference. But with the help of the fixed size, I'm able to tell 50% more. But I also wanted to know how much difference we have from professor to associate professor, professors to assistant professor, professors to senior professor. Means, let me open this. We have 1, 2, 4. Okay. Now, one you can call it as a senior professor. Now, one you can call it as a senior professor. I'm comparing senior professor with assistant professor. I'm comparing senior professor with professor. I'm comparing senior professor with associate professor. How many comparisons I'm doing it? With every individual, I'm comparing with the remaining 3 members. Similarly, I'm going to compare with the professor with the senior professor, professor with associate professor, professor with assistant professor. Similarly, assistant professor. So what I want to say that I want to see within the groups, between the groups. I don't want simply whether there is a significance or not. I want to know whether there is a significant difference between performance of the academic level of the employees. This is academic level. Okay. Academic level, like a professor, senior professor, associate professor, assistant professor. Second variable is performance. I just don't want to know only whether there is a significant difference or not. Point number 1, p-value, whether there is a significant difference or not. Point number 2, effect size. How much effect size? How much difference we have it? Effect size. Third point, I also wanted to know. I just want to know from one person to remaining 3 other person. I want to compare. Okay, somebody saying that assistant professor, I said at the beginning, just an example. Assistant professor is performing better than senior professor. If I can say that, I also going to compare assistant professor with the professor, assistant professor with the associate professor. So every individual I'm going to compare with the remaining 3. So in order to get this kind of results, we have to conduct the post hoc test. Where is that? This is called post hoc test. Post hoc test is going to help us to get the multiple comparisons. You can compare with one category to the remaining other categories. Okay. Let's see with the help of the data. Okay. Now just go to the post hoc test. One more important point. We are going to conduct post hoc test only when we get significant results. When we get the significant results of ANOVA test. Okay. In case ANOVA test results are not significant, there is no point of conducting post hoc test. I'm repeating again. Whenever we are going to conduct, whenever we get the ANOVA test significant results, then only there is a point of conducting post hoc test. Because, for example, if your results are saying that there is no significant difference between any level of employees, so there is no point of looking at comparisons. But if you get significant results, then you can see, okay, there is a significant difference, but which employee is performing better than as compared with the remaining 3 point of view. Second point of post hoc analysis test is that if you are getting equal variance assumed, we'll go for one type of post hoc test, like as you can see here. If equal variance is not assumed, we'll go for one type of post hoc test. If equal variance is not assumed, we'll go for another type of test. So what I suggest that right now, we're not going to conduct the post hoc test. Go to options. I want to see descriptives. I want to see homogeneity of the test. Look at our data requirements. We have to see the homogeneity of the variance. Okay. Homogeneity of the variance. There is one more important concept as a part of ANOVA test. I don't know how many of you can able to recollect. As a part of independent sample test, I mentioned that if you are able to fulfill the assumption of homogeneity of the variance, we are going to take the first row of the independent sample test results. As a part of independent sample test, yesterday we clearly mentioned that if you are able to fulfill the assumption of homogeneity of the variance, we are going to take the values of the first row of the t-test, independent sample t-test. If you are not able to fulfill the assumption of homogeneity, we'll take the second row of the independent sample t-test. Now, when it comes to the ANOVA, if you are going to get the p-value, if you are going to get the homogeneity of the test assumption, if you are able to fulfill it, that is fine. If you are not able to fulfill the assumption of homogeneity of the variance, we are going to take the values of Welch test. If you are able to fulfill the assumption of homogeneity of the variance test, that is fine. If you are not able to fulfill the assumption of homogeneity of the variance, we'll go for Welch test. Okay. I also wanted to see not only statistical test, I also wanted to see plot. I want to present my data in the form of plot as well, in the form of diagram as well. Okay. Continue. Okay. Look at the results. We got so many outputs. First output, we got the one-way ANOVA result. We got the one-way ANOVA result. Now, look at the mean value. Sexual diffuse. If you look at the sample size, our total sample, we have 198 respondents. And out of 198 respondents, we have majority of the people belongs to androgenesis and very less number, very negligible number of people belongs to sexual diffuse. The people, those who consider neither good at feminine nor masculine, that is called sexual diffuse. Okay. Now, if you look at the performance, of the leaders, 3.8, 5.7, 6.5, 7.1. Means, if you look at the mean score of employee performance or leaders performance, the people belongs to androgenesis, their performance is very high as compared with the remaining 3 other categories. Okay. Followed by feminine sex type, then masculine type, and least one is sexual diffuse. Okay. Now this is one understanding. We are able to see that there are differences between the groups. Okay, there are differences groups here. We have 4 groups that we can able to see the difference between the groups. Okay. Now I just want to know what are the differences that you are having it. Whether is it statistically having significance? So for that, I'm conducting ANOVA test. Before looking at the ANOVA test result, we have to see the value of homogeneity of the variance. Just like a normality test, we have to fulfill the assumption of homogeneity of the variance. Our p-value should be greater than 0.05. Looking at this particular p-value, I'm able to see that we are able to fulfill the assumption of homogeneity of the variance. But imagine that we are not able to fulfill the assumption of homogeneity of the variance. I'm repeating again. Right now, we are able to fulfill the assumption of homogeneity because our p-value is greater than 0.05. It is just 0.057. Okay. Imagine that our value was less than 0.05. In that case, we have to take, there is concept called Welch test. We have to take the values of the Welch test results. Now, just because it is able to fulfill the value, it is able to fulfill the assumption of homogeneous variance, we are going to take the ANOVA result. If this particular value is less than 0.05, instead of taking the values of ANOVA, we are going to take the values of Welch test. I believe I'm not confusing you all. If there is any issue, please let me know. Okay. Let me repeat once again. If you are able to fulfill the assumption of homogeneous variance, we'll take the values of ANOVA test result. If this particular values of homogeneous variance is not fulfilled, instead of taking the ANOVA result, we are going to take the values of Welch test result. Okay? You got the point? Now, as our assumption is fulfilled, we are going to take the values of ANOVA test result. And ANOVA test result shows that our p-value less than 0.05. It means our null hypothesis shows that, what is our hypothesis? All types of leader performance means are equal. Means we are going to reject this particular null hypothesis because there are so many differences. There are significant differences between each and every type of 6-role type. Okay. Now, as we are able to fulfill the assumption of homogeneity of the variance, as we are able to fulfill that there are significant differences, we are going to conduct the post hoc analysis. In order to conduct the post hoc analysis, go to analyze, compare means, go to one-way ANOVA, just click on post hoc test. As we are able to fulfill the assumption of homogeneity, we are going to take the equal variance assumed. If you're not able to fulfill the assumption of homogeneity, we'll take this particular values. So most popular test is Tukey test. Most popular test within the equal variance assumed is Tukey test. But it happens in case if it happens that we have to take within the equal variance not assumed. In that case, you can take most popular. There are based on the literature review, you can able to either opt for Donate test or Games Hall test. These are the two popular tests which you can opt whenever you find that you are not able to fulfill the assumption of homogeneity. As we are able to fulfill the assumption of homogeneity, we are going to go ahead with the Tukey test. Okay. Just click on OK. Continue. OK. Now look at the result here. Let me copy this. Okay. Now, what is the specialty of the post hoc test? I'm comparing 6-role diffuse with masculine type, 6-role diffuse with feminine type, 6-role diffuse with androgenesis. Means each group I'm comparing with the remaining other 3 groups. Look at here. Again, masculine with 6-role diffuse, masculine with feminine, masculine with androgenesis. So like that you can able to compare. Now, mean difference 6-role diffuse minus masculine sex type. If you want to understand this figure, if you want to understand this particular figure, go to this, copy this, copy. Look at here. 6-role diffuse 3.8 minus 5.7. If you calculate it, we'll get 1.89. Okay. Similarly, 6-year-old diffuse minus 3.8 minus 6.5. You'll get this particular result. Okay. Now you can able to see the difference here between sexual diffuse and masculine sex type. Are there any differences? P-value is greater than 0.05 means there is no significant difference. Sexual diffuse versus masculine type means there are significant differences between these two groups. What we did based on the ANOVA test result, we got the overall there are differences between the groups. Now we are going to see within the groups. This particular data is going to help us. Overall, we got ANOVA test results, which is talking about there are differences. Okay. Now here we are able to see one group with another group. Are they significant? If I am comparing with sexual diffuse with masculine sex type, p-value is greater than 0.5. There is no significant difference. But sexual diffuse versus masculine type, there are significant differences. Sexual diffuse versus androgenesis, there are significant differences. That's how post hoc test is going to help us to understand. But we are going to conduct post hoc test whenever our ANOVA test results will find significant results. If p-value is less than 0.05, then only you can go for talking about post hoc test. Otherwise, there is no point of talking about post hoc test. Last one, means plot. Look at the mean plot here. If somebody can explain, any volunteers can explain what it is, what is your understanding about this mean plot? Anyone randomly? If you look at this particular part, sexual diffuse performance is very low. Masculine type is next one, and androgenous performance is performing very high. Same thing, whatever you got as the mean score, whatever you got in the mean score, that is performed in the form of plot wise. So you can take it, you can able to see that how it is presented in the form of graph. Okay. So this is all about how to conduct the ANOVA test. Before going to next, I also wanted to introduce you. I don't discuss. There are other types of ANOVA test. ANOVA of big family we have it. Let me show you the family. What we did today from last, I don't know time, from last 30 minutes or 20 minutes, we have conducted only one test, that is one-way ANOVA. In order to conduct the one-way ANOVA, we need one continuous, one dependent variable, one independent variable. Okay. Now, if there are a few more families, there is like two-way ANOVA. In that case, we are going to have one dependent variable. We are going to have two independent variables. Let's take, for example, effect of education background. There is one independent variable, that is categorical data, and the level of experience, there is second independent variable. Dependent variable income only. Dependent variable income only means right now we have done what we have done. Sexual type is one independent variable, and leadership performance is one dependent variable. But imagine that I'm looking at the gender. I have male, female, transgender, and sexual type or academic level. If I'm adding more than one independent variable, I'm going to go ahead with conducting two-way ANOVA test. Okay. We have a few more concepts like one-way ANCOVA. When you have to conduct this particular test, one dependent variable, one nominal, and one scale data. One categorical data, one scale data we have. In that case, we are going to conduct ANCOVA test, MANOVA test, two-way MANOVA, one-way MANCOVA. So like that, there are, it is a huge family. Okay. So I just brought this particular examples for your reference. Okay. Any questions before going to chi-square test? Is it clear so far? I believe some of you might be practicing whenever you get the free time. If you don't practice it, Professor Binit, he might be conducting so many programs. But if you don't practice it, if you don't look at it, maybe sometime. I'm not saying that you have to practice right now, but whenever you get the time, if you can able to relook at it, then only you will learn it. Otherwise, while listening, you feel that yes, you are able to catch it. Okay. But actually, if you start practicing it, you don't forget it. So if you don't practice, after 2 days, after a few days, you'll forget it. Okay. So this is my, based on my experience, I'm talking about it. Okay. Now coming to the chi-square test. Within chi-square test, we have two types of statistical test. But the question is, when to go for chi-square test? When to go for chi-square test? Whenever we have categorical data like nominal data, ordinal data, or one categorical data, we have only one variable. Instead of simply preparing a frequency table, you want to show that your supervisor or you want to show your examiner that you have conducted some statistical test. See, if you are going to simply show your frequency charts, people think that it's a simple study. You haven't make any attempt to learn or you haven't make any attempt to come up with some insights as an outcome of your research work. But if you're able to come up with next level of frequency, that is chi-square test. Next level of frequency is cross tabulation. Another level is coming with chi-square test. Okay. So within the chi-square test, we have two types of test. If I have only one variable, so I'm going to choose one type of statistical test. That is nothing but chi-square goodness of fit test. If I have only one variable, I'm going to choose chi-square goodness of fit test. If I have two categorical data like gender and rural area, or gender and ICT competency like low competency, high competency, and all. If you have two categorical data, or 2 into 3, or 3 into 2, whatever maybe, if I am going to have it, I'll go for chi-square test of independence. So let's see one by one how to conduct it. Okay. First one I am taking chi-square test of independence. When you have two categorical data from a single population, I'm talking about your annual income. I converted your annual income into qualitative data. Like yesterday, we have converted our age into qualitative data. Like we have done like 21 to 30, 31 to 40. I can able to say that young age, middle age, elder age, right? That way I can able to do that. Now, similarly, we have one way hypothesis. In order to conduct the chi-square test result, my hypothesis is that respondent's gender is not associated with ICT competencies. I'm seeing that whether people belongs to male category, are they having higher information and communication technology skills or competencies as compared with the female. I'm comparing with male and female, whether who is having high competency, who is having low competency, who is having middle level ICT competency. If that is my objective, if that is my hypothesis, here I have two categorical data. One is gender, male, female. Second variable is ICT competencies. ICT competencies, I have low competency, middle competency, high competency. So both the variables are categorical data. So I can go for conducting chi-square test of independence. Okay. But before conducting the test, I want to tell you a few important points. Just like as a part of parametric statistical test, how we have to fulfill certain criteria. In the similar line, if you want to conduct the chi-square test, there are certain assumptions, certain eligibility criteria are supposed to be fulfilled. We have two categorical variable, we are able to fulfill it. Two or more categories, yes, for example, ICT competency, we have three categories like low competency, middle competency, high competency, we can able to fulfill. It can be two or more, okay. Independence of observations, that is part of your data collection. The most important part, expected frequency for each cell are at least 1. What it is? Let's take for example. I'm showing you one cross tabulation. Look at here. This is the cross tabulation. Don't mind from the layman point of view, I'm explaining from the point of PhD scholars point of view. This is called column. Okay. This is column. This is the row. We all know about it. Everybody knows we have column, we have rows. Okay. Now, this is called cell. This is called cell. This is called cell. We have column, we have rows, and we also have cell. This is one cell. This is another cell. This is another cell. Like that, we have so many. We have 9 cells are here. We have 9 cells in this particular data. 3, 3, 9. 9 cells we have it. Now come to this particular assumptions. Expected frequencies. There is a difference between observed frequency, expected frequency. Observed means the data that you have collected from the field. Expected means the software is going to generate based on certain assumptions. It is going to give you some expected frequencies. But that expected frequency of each cell should be at least 1. I'm going to show you what is expected frequency, how to get it after a certain period of time. The point that I want to highlight right now is that the expected frequency of the cell minimum should be 1. But there is a possibility that, for example, here in this particular case, we got 0. There is a possibility that you may get the 0 also sometimes. But at least it should be greater than 80% of your cells should have minimum 5 count. Look at this next one. Expected frequency should be at least 5 count, at least 5 for the majority of the 80% of the cells. If there are 9 cells, 80% of the 9 cells should have at least 5, more than 5 count. I think yesterday, while talking about cross tabulation, I already mentioned. Now, maybe it may be repeating for some of you. I already mentioned to you. So this is also one of the important criteria. You have to see whether are you able to fulfill the assumption of the count, expected frequency count or not. Okay. Now, please go to the data set. Let me close ANOVA data set. Chi-square test data set I'm opening. Chi-square test set data set I'm opening here. I request all of you to please open the Chi-square data set. Please come to the variable view. Please come to the variable view. Okay, happiness is here. Now, as per our hypothesis, we are looking at the gender, one variable, and we are looking at the ICT competency. Now, when it comes to gender, we have 2 categories, male 1, female 2. Next one we have ICT competencies. We have low ICT competency, average ICT competency, high level ICT competency. Okay, we have 3 categories. So this is called 2 into 3 table. How it is called 2 into 3 table? how it is called 2 into 3 table? There is a possibility that you may get 2 into 3 table, 3 into 2 table. This is the most important part in order to understand output of your data. The nature of the table is going to decide what kind of statistical test that you're going to have. I'll explain. I'll come to this particular point coming days. Right. So right now you need to see that it is 2 because there are male, female. This is 3 because there are low ICT competency, medium ICT competency, high ICT competency. So this is called 2 into 3 table. So there is also possibility that 3 into 2 also depends on the row and column you selected. There is a possible like, okay. Now come to the test as a part of the chi-square. We have 3 categories, okay. How to conduct the chi-square test? Go to analyze, go to analyze, go to analyze, descriptive statistics, go to analyze, descriptive statistics. There is option called explore. Sorry. Go to analyze, descriptive statistics, go to cross tabulation, go to cross tabulation. As I mentioned earlier, it is advanced version of cross tabulation. After selecting the cross tabulation, select the table or rows or columns as per choice. Like gender, I'm choosing row wise. ICT competency, I'm choosing column wise. Okay. Now go to exact. Here we don't have anything to do with this. Go to statistics. Go to statistics. We are going to select chi-square test. Go to statistics. Here we are going to select chi-square test. Next and most important part, pi and Karmas value. Pi and Karmas value. I'll tell you what it is. Okay. I hope those are practicing along with me. You are there with me. I have selected chi-square test. I have selected pi and Karmas value. Okay. Just continue. Go to the cells. Go to the cells. We know observed values, what it is. Observed values is nothing but the values that you are collecting, the data that you collected it. And expected value is the one which we are expecting that our frequency expected we are generating from with the data. Okay. I also wanted to get the total value. Now the expected value as a part of test of independence may not be required. Observed value, total value will take care of it. Continue. Click on OK. Now look at the result here. We got the cross tabulation. We got the chi-square test result. As per the cross tabulation, you can see that there are total 656. We got the data from 656 people and we don't have any missing value. Now out of 656 people, 58% of the people belongs to male category, 41.42% people belongs to female category. And we are able to analyze what this particular data is talking about it. Like we can able to see that within the male category, majority of the people belongs to male category, they have low ICT competencies. Majority of the male people belongs to majority of the people belongs to male category. They have highest number of people have low ICT competencies. Whereas when it comes to the female, we can see that high competency male have, average competency male have it, and low ICT competency also male percentage wise. Okay. So we are going to analyze this particular data based on the rows and columns we got it. Now, I just want to know whether there is any significant difference between male and female. Now, if you look at our chi-square test result, our chi-square test result shows that our p-value is greater than 0.05. It means there is no significant association. Whenever you are going to talk about chi-square test, instead of talking about relationship, instead of talking about significant difference, you can say that there's a significant association. There is a difference. There's no association. There's no significant association between gender and ICT competencies. Means both male and female, though there are differences, there is no significant association. There are no much changes. As you can see that nobody is performing very high. When it talk about male, 10.5, 9.3. Though there are differences, but differences are not having much. Okay. Similarly, 6.1, 11.7, 36, 26. Imagine that our chi-square test results are significant. Imagine that our chi-square test results are not are significant. If you get the significant results, we look at the pi and Karmas value. But there are two, pi value, Karmas value. When to go for pi, when to go for Karmas. If your table is 2 into 2, if your table is 2 into 2, you'll go for pi value. If your table is 2 into 3 or 3 into 2, in that case, we'll take Karmas value. But right now, our p-value is greater than 0.05. We didn't get the significant results. So there's no point of talking about pi and Karmas value. The pi and Karmas value is nothing but it is almost like effect size. Like for example, when you are discussing about ANOVA test or when you're talking about t-test, like one sample t-test, independent sample t-test, paid sample t-test, we are talking about significant effect size. Like if you want to put in the form of percentage, just like that, as a part of chi-square test, we have pi and Karmas value, but we will take these particular values only when you get the significant results of it. Okay, that is the main thing. I hope it is clear. Now, coming to the next one. Chi-square goodness of fit test is a single sample non-parametric. Whenever you have only one variable, that is also, it can be nominal data or it can be ordinal data. In that case, we can go for goodness of fit test. Just open your same sample data set. We have job, house. I'm looking at the gift. I'm looking at the gift as a one variable. Okay. And today's date is 29th December. Sorry, November. And we are going to have New Year. And we are also going to have Sankranti. Pongal festival is coming up. And all of your employers is giving some promise. They're asking that you can opt for any one of the option. Okay, let's say for example in Gujarat there is one diamond factory. I don't know whether it's factory or industry. So for Diwali they used to get some kind of costly gift like a car, house, okay, diamonds. Just imagine that your employee is opting. He's asking that opt for any of the choice. Like first one is job, second job is already have it. So third one is house and money. Now, as an employer, as the person who is giving some kind of gift, somebody who want to give you gift, he's assuming that there are 50 people and 50 people are going to opt equally. Like when I say 50%, 50 people means 15, 15, 15, 45, like 17, 17, 17%. Okay. Let's say, for example, if there are 100 people, 33.3, 33.3, 33.3. I'm expecting that my expected value is that 33.3 for job, 33.3 for house, 33.3 for money. As a researcher, as a owner, as a employer, I'm assuming that my employees are going to opt equally, equal proportion, this particular gift. That is my assumption before conducting the test. So my expected value is 33.3, 33.3, 33.3. Once we collect the data, then I'll come to know what is observed frequency, right? So in order to conduct the chi-square goodness of fit test, go to analyze, go to analyze. If you scroll your cursor down, there is option called non-parametric test. There is option called non-parametric test. Right side of the window, right side of this particular non-parametric test, we have one more option, chi-square test. I hope you're able to see this. Non-parametric test right side, we have legacy dialogues. Within the legacy dialogues, we have chi-square test. Just click on it. My variable is gift. Okay. My variable is gift. We have three options. One is job, second one is money, third one is house. Okay. Nothing to do with exact. Go to the options. Go to the options. I want to see the descriptive statistics. I want to see actually how many they have opted for it. Okay. And secondly, expected values. All categories equal. I'm assuming that if there are 100 people and if I'm giving three gifts, each gift opted by my employee equally means equal proportion is going to be opted. Okay. So I'm assuming that all categories are equally opted. Okay. So by default is already there. Okay. Just click on OK. Now just look at this particular data. Copy. Look at this particular data here. I'm assuming that there are how many employees? 656 employees we have it. There are 656 employees we had. If you take equal, if you are expecting equally, on average it will be like 219. 219 you are expecting it, like 218 like that. Okay. Supposed to be 218, 218, 218. As an employee, you're expecting that your expected frequency is 218. Okay. But if you look at the reality, majority of the people, like 435 people opted for the job. 435 people opted for the job, followed by 169. Very less number of people opted for money. We know the justification. We know the reason for it. Okay. If you have job, everything will come. Okay. That's one thing. So it depends on the house, property, location wise. Some people might have opted for it. So whatever maybe, there is a huge difference between expected frequency and observed frequency. How much difference we have it? 435 minus 218. How much difference? 216. 169 minus 218 minus 49. 52 minus 218 minus 166. Now I'm able to see a lot of changes. Whether this particular changes having any significant association. Okay. For that, our chi-square test result shows that p-value is less than 0.05. It means this particular differences is happening not accidentally. There are significant differences we have it. We can able to see that p-value is less than 0.05. It means there is a significant difference between each group opting for the uh, different kind of gift, job, housing, money. Okay. I think there is no effect size. Let me see whether I have missed it. We don't have effect size. Okay. For the Goodness of fit test, we don't have effect size. Only significant results we are able to see that. Okay. So this is all about what is ANOVA test, what is chi-square test. We have conducted two types of chi-square test. Now let me go to with the correlation test. Okay. When to conduct the correlation test? What is correlation? When to conduct the correlation? The main object of correlation is to see the relationship between two quantitative variables. Or I can say that two variables. If you are getting two quantitative variables, we'll go with Pearson correlation test. In order to conduct the correlation test, we should have two variables. Two variables must be quantitative. Means either they can be interval data, or it can be ratio data, or it can be both together. If you have nominal data, ordinal data, there are two types of correlation. First one is Pearson correlation. Pearson correlation, if you want to conduct it, we should have two quantitative data. Imagine that I have employee annual income, and employee annual performance, employee annual expenses, employee annual performance. Let's take, for example, all of you are waiting for 8th pay commission, right? Now, employee annual income and employee annual expenses. If income increases, expenditure increasing or decreasing? If income is increasing, whether income increasing or decreasing. If I want to understand the relationship between two quantitative variables, I'll go for Pearson correlation test. Pearson correlation is nothing but parametric statistics. As a part of parametric statistics, we have Pearson correlation test. Now, when it comes to the correlation, either you'll get positive relationship or you'll get negative relationship, or there is no relationship. If you're getting either positive, negative, it is called linear relationship. Means one variable increasing, other variable might increase or decrease. It is called linear relationship. But if there is no relationship, neither one variable increasing nor another variable increasing, that is called no relationship. If we don't have relationship, there is no point of conducting correlation. Okay. Now, a statistical test that is used to analyze the strength and direction of the relationship between two quantitative variables. It is called a correlation analysis. If you want to understand strength and direction, like for example, I am able to tell you if one variable increases, other variable is increasing or decreasing. This is called direction. Whether it's positive or negative. If one variable increases, other variable increase or decrease. Something we are talking about direction. Apart from the direction, I'm also going to talk about strength of the direction. Strength of this particular relationship. I'm going to talk about it. Okay. So there is a possibility of having positive relationship or negative relationship. But if there is no relationship, there is no point of conducting it. Our relationship can be positive or negative. Let's take for example, when I say positive relationship, one variable increases, other variable also increase. Like for example, a study hour increases, test score also going to increase. This is called positive correlationship. Okay. Now, when it comes to the negative relationship, as screen time increases, sleep duration decreases. I think this is the actual what we are doing, not for study purpose, not for teaching purpose. I'm talking about the mobile phone. we can able to estimate ourselves, we can able to understand ourselves, how much screen time increased from last 10 years after having so much of social media platforms. Our screen time increased. So as a result, it is having any kind of impact on. As a result, you can able to see impact on sleep. It also can see impact on the number of hours we are sleeping on it. It's also going to have impact on number of hours we are working. It's also going to have impact on our performance. So whatever it is, if screen time increases, sleep duration decreases. So there is a negative relationship. In order to conduct the correlation test, we should have either positive linear relationship or negative relationship. But if you are going to have no relationship, if the variables are unrelated, there is a non-linear relationship, Pearson correlation is not appropriate. At the beginning, I mentioned that there are two types of correlation test. One is Pearson correlation. Second one is Spearman correlation. For conducting Pearson correlation test, we should have linear relationship. Second one, there should be two quantitative variables. Third one, two quantitative variables data must be normally distributed. Let me show you the assumptions. There should be linear relationship. It can be positive, it can be negative, but linearity, there should be some relationship. Coming to the variables, we required two variables, two quantitative variables. It can be either interval or ratio, or it can be both interval or it can be both ratio. Okay. So we required two quantitative variables. Independence of observation, it is as a part of your data collection. Normality test. Normality test is nothing but what we have done at the beginning of session today and yesterday also, to see whether our data is having normality or not. Now the point is that we know that we have two variables as a part of our, let me open the data set. Open the same data set, that is quantitative data analysis using SPSS. Just open the same data set, quantitative data analysis using SPSS. If you look at this particular data, we have knowledge score, we have calcium score. We have two quantitative variables we have it. If you look at the values, we don't have any values here, like we haven't given any code. It means it is a quantitative data. Let me see the data view. Let me see the data view. We have knowledge score. What is the calcium knowledge? Let me explain what is the data it is. So right now, as a part of Indian Sociological Society or maybe other organizations, they are conducting mixed method research methodology. Okay, they are conducting mixed method research methodology, and it is a 12 weeks course. Okay, now after 12 weeks, imagine that organizations are conducting test for 50 marks. Organizations are conducting test for the 50 marks. So we have 50 marks score for how many people? We have 50 participants, and 50 participants, we have maximum 50 marks they can score. Least can be 0 marks or 1 mark. Okay. So these are the marks we got it for the 50 people. Now coming to the calcium intake, instead of mixed research methodology, they have conducted training program on diet. What kind of diet we have to take? What kind of calcium we have to take? What kind of proteins we have to take? It is like health awareness program. Okay. So they have conducted training program for 12 days on health awareness like diet, proteins, calcium, and all. Okay. Now after conducting the test, they wanted to see on average how much calcium intake you are taking per day after attending this particular program. No, the person who got out of 50, 10 marks, what his her calcium intake per day in terms of milligrams, 450 milligrams. The person who got 42 marks out of 50, what is that particular respondent, that particular scholar or academician calcium intake? Okay. Now, if you want to see two candidates, three candidates, I can able to come to the conclusion. But as a researcher, you are collecting data from 50 people, 100 people, 200 people. Why we are looking at the manually? We also wanted to see whether is there any significance. So we are going to conduct the correlation test. We have two quantitative variables, knowledge and calcium intake. Now, as a part of our data requirements, we know how to conduct the normality test. Right now, I'm not doing it. As a part of independence observations, we are going to take care of it at the time of data collection. We are able to fulfill the data because we have two continuous data. One is in a knowledge score, second is calcium intake. But there is one more assumption, that is linearity test. We don't know what it is, whether it is having a positive relationship or negative relationship. So we have to conduct the one more assumption, linearity test. In order to conduct the linearity test, we have very important uh, uh, diagram or a plot, or I can say that figure, that is called scatter plot. I think yesterday I was talking about it, how to design graphs, charts. In order to prepare the scatter plot, go to graphs. In order to create the scatter plot, go to graphs. There is option called legacy dialogues. Either you can go directly to chart builder. There is one more option, legacy dialogues. If you go to legacy dialogues, if you scroll your cursor down, there is option called scatter plot. Scatter plot dot, we have scatter plot. Okay. Just click on it. I got different types of scatter plot. I want to do it simple scatter plot. So I selected, you can choose whichever you want to do it. I want to have simple scatter plot. Just click on define. Click on define. Now, as a part of correlation test, here we are not looking at independent variable, dependent variable here. Okay. We are only looking at, there are two variables. We are required only two continuous data. We are not looking at the independent, dependent variable here. Okay. So just here, you can give randomly any number. You can choose x-axis, y-axis randomly. You don't need to see which is independent, which is dependent here. So calcium intake, I'm giving y-axis. Knowledge score, I'm giving x-axis. Okay. If you want any make beautifications like title and all, you can make later on. Okay. Just select it. Just click on OK. Just select it and click on OK. Now I got this particular scatter plot. Imagine that for the first time you are doing this particular scatter plot. I'm not able to understand how to read this particular scatter plot. So what I will do, I'll just double click on it. I'll open the chart editor. I have got so many options. If you look at this particular option, there is one line called interpolation line. There is one line called interpolation line. Okay. Just click on that particular interpolation line. I got one line, diagonal line here. Okay. Now it is showing the how data is divided. It is showing how data is divided. It shows that from 0, it is going up. It is giving some indication that from 0, it is increasing. Some line, this particular line is going crossly, is not falling. I am not able to see any fluctuations also. It's going straightly, I mean, not exactly straight, this is a diagonal line. Okay. Now, second point, I can also see that at the 0, it is 0. As the knowledge score, like 10, 20, 30, 40, 50. Let me, I'm just copying it. Okay. At 0, at 10, 20, 30, 40, 50. Means there are people who got 48 score knowledge test score. There are people who got 10 also. There are people out of 50 marks. There are people who got 10 marks. There are people who got around 48 marks. Okay. That's what we have observed manually when we are looking at the data. Second one, we also saw the data. There are people who are taking 450 milligrams per day. I think this one, 450 milligrams per day, least one, 440 milligrams per day. And we also have seen there are people who are taking more than 1000, like 1100 plus somewhere close to 1100. Okay. Now the person who is taking 1100 milligrams per day, if you look at the test score, above 40, somewhere close to 44, 45, somewhere. Okay. Or if you look at overall, if you calculate the people those are got the people those are taking 600 milligrams per day, their average marks are nearly more than 30. Majority of the people are above 30, above 25 onwards. You are able to see that, right? Means the people those are getting the people those are taking 600 milligrams per day, their score is very less here. Their test score is very less. Of course, there are people, someone got 40 marks, like 38 marks somewhere, but calcium intake is less. It's not even five. It is somewhere close to 500. But the people those are getting 800, the people those are taking 800 calcium intake, you can see that they are above 20 marks. The people those who got above 30 marks, their calcium intake is gone above 900. There is no single person. There is no single person who got less than 20 taking more than 1000 calcium intake. But there is one person whose marks are less than 10 or maybe 10, but his calcium intake is somewhere 950 and 900. Okay. Now, what I am saying here as a part of this particular chart editor, there are two options I want to explain. There are 2 points I want to explain. The person who is getting 40, between 40 to 50 marks, nobody has less than 600 milligrams for calcium intake, means their calcium intake is very high. I hope I'm not confusing you. If you look at this marks 40 to 50, between 40 to 50, the people, those who got marks between 40 to 50, their calcium intake is above 700 only. That is one thing I can see that. Even if you take 30 marks, their calcium intake is very high. So if one variable increases, other variable also increasing. There is a linear relationship. Now, what was I discussed at the beginning? We should have linear relationship. It can be positive relationship or it can be negative relationship. Positive relationship means if one variable increases, other variable also increasing. Means if knowledge test score increases, calcium intake also increasing. Right? So this is called positive correlationship. But if I want to say negative relationship means if one variable increasing, other variable decreasing. That is called negative relationship. Basically, we should have linear, either it can be positive or it can be negative. Now we are able to see there is a positive linear relationship. But I want to know what is the strength of the relationship. In order to understand the strength of the relationship, we are going to conduct the correlation test. As we are able to fulfill the assumption of linear relationship, we are having two quantitative variables. We are going to conduct the correlation test. Within the correlation test, we have within the bivariate, means we have two quantitative variables. We are taking two variables. That's called bivariate. Okay. Knowledge test score, calcium intake. Right now, I haven't conducted normality test. We all know how to conduct the normality test, right? Just looking at the availability of time, I'm not doing with that. Okay. Now, please look at these particular options here. Please look at these particular options here. Whenever we have two quantitative variables, whenever we have two variables, the two variables or belongs to quantitative will go for PSN. But imagine that instead of having two quantitative variables, I have one quantitative variable, one categorical data. I'll go for Spearman correlation. One more alternative why we'll go for Spearman correlation is that we didn't achieve the linear relationship. We didn't achieve the positive relationship or negative relationship. There is no relationship. In that case, we'll go for Spearman correlation. Third choice, we are able to fulfill the assumption of linear relationship, but our data not distributed normally. So in that case also, we can go for Spearman correlation. Spearman correlation is a part of non-parametric statistic. Okay. Now, as we are able to fulfill the assumptions, by default, Pearson correlation options. I want to see mean and standard deviation. I want to see mean and standard deviation value. I also wanted to see a cross product. I think there is no required. Just click on this. Click on OK. So we got the descriptive values. Out of 50, there are 50 respondents, and we have conducted a knowledge test score for 50 marks. On average, mean score is 29. They got 29 marks, average marks for 50. Okay. When it comes to the calcium intake, 50 people average score is, on average, 50 people they are taking average score is 769 milligrams per day. 769 milligrams per day they are taking on it. Now, we understood with the help of the scatter plot, there is a positive linear relationship. Now, we have to see whether there is a significant relationship. With the p-value, we are able to say that there is a significant relationship between knowledge test score and calcium intake. That's point number 2. Point number 3, what is the strength of the relationship? What is the strength of the relationship? If it is a positive relationship, it will be in the form of plus. If it is a negative linear relationship, we'll get in the minus. Okay, but we also have a few more way how we can interpret the data. Let's look at this particular data set. This is how we are going to interpret your data. Right now, our test result is, if I'm not wrong, 0.610. Please remember this particular point. 0.610. 0.610, it is coming here. Means there is a moderate positive. I can say that moderate positive here only, moderate positive correlationship. But in case we have minus, then in that case, I'm going to say moderate negative correlation. So depends on the plus and minus value. You can interpret the data, whether it's going to be positive, it is going to be negative. If I'm getting values between 0.90 and to 1, very high positive correlation. So depends on the minus and plus symbols, you can able to interpret this particular data. Okay, this is the most important aspect of it. So I think we have 10 to 15 minutes time before going to question answers. Let me complete regression part. For the same data set, what is the difference between correlation and regression? Correlation tests help us to understand whether there is a relationship. If there is a relationship, what kind of relationship? Positive, negative, or no relationship. Further, it is also going to help us whether there is a significant relationship. If yes, what is the strength of the relationship? So these are the 3 to 4 points. But when it comes to the regression test not only help us to understand whether there is a positive relationship, negative relationship, it is also going to help us cause and effect relationship. Means, as an employer, employee satisfaction depends on so many factors like work culture, leadership style, pay and all. Each independent variable is going to influence the dependent variable. If there are three factors like salary, work culture, leadership style, out of these three factors, which factor is highly influencing the employee motivation or employee performance or retaining employees in your particular organization for a longer period of time. Every variable is playing an important role. Like every independent variable have some kind of influence, but out of these three, which independent variable is having more influence? Like for example, as a part of prediction, as a part of if you want to take some decision making, if you want to see cause and effect relationship, in that case, one can go for regression test. How to conduct the regression test? Go to analyze, regression, just like ANOVA test. It is a, I can say that, I don't know whether I can call it, it is huge family, big family we have it. Uh, like simple linear regression, multiple linear regression, binomial logistic regression, ordinal logistic regression, multinomial logistic regression. So it depends on your purpose of the data that you have. Right now, we are going ahead simple linear regression test. So we need two quantitative variables. Knowledge test score is independent variable. Calcium intake is dependent variable. Statistics. I want to see descriptive statistics. I want to see R square. Confidence interval. Continue. I also wanted to scatter plot. We already done. I think we no need to do this particular scatter plot right now. Go to options. Nothing is to date. Just click on OK. Even as a part of regression, we have to conduct the scatter plot to see what kind of relationship we have. Okay. Now just look at here. We have three outputs. Our correlation test is 0.61. There is a relationship between independent dependent variable is 0.61. Okay. And our ANOVA test result, that is this particular regression test value is less than 0.05. It means there is a significant difference between independent variable and dependent variable. How much significant we have it? That is 0.37. Means knowledge test score is influencing 37% whatever changes are happening in the dependent variable. I'm repeating again. You want to see cause and effect relationship. How independent variable is influencing the dependent variable. Knowledge test score is able to explain out of 100%, 37% whatever the changes are happening in the dependent variable are due to that particular independent variable. What is that independent variable? Knowledge test score. Imagine that there are uh, more than one variable, multiple relationship, like knowledge, pay, and work culture. Now we are able to say that which independent variable have more influence. That is called multiple linear regression test. So as a part of simple linear regression test, 37% I'm able to say confidently saying that whatever the changes are happening in the dependent variable are due to change in the independent variable. At least you should get 50%. If you want to say that the model that you are developing as a part of your research work, if you get R square value 0.50, at least that is good model. At least if you are able to expect, if you are able to guess, predict at least 50%. But if it's less than 0.50, people may say that is not at all good value. 37 means hardly 40% of it. Okay. Now, one more important point. First point is we are able to explain what are the changes happening dependent variable, that is 40% due to change in independent variable. Now here there is one more important point. For every unit of increase in knowledge test score leads to 9.4 milligrams intake in the dependent variable. I'm repeating again. 1 unit of change in independent variable leads to 9.49 milligrams intake is going to influence in the dependent variable. So this is what all about regression and correlation, ANOVA test, and what else? What we discussed today? Chi-square test result. This is what from my side, I have covered it. And if there are any questions, I'm to go for question answers. If there are any questions, please let me know so I can able to answer a couple of questions. Or if required, I'll come forward and I'll get back to you tomorrow if I'm not able to answer anything. Okay. I have already shared my YouTube channel with you. In case if you like the session, if you would like to watch once again, please subscribe to my YouTube channel if you like it in case. Okay. Are there any questions? Is it helpful? I'm sharing my YouTube channel once again here in the chat box. Actually, I didn't discuss entire output. I've given the overview of the output. If you have any questions, if you need to any explanation of any of the output, any of the statistics, please let me know. Thank you, Dr. Manjula. Thank you so much. Tomorrow session timing 6:30. I'm really sorry today. There was urgent meeting with higher authorities, especially CM of Gujarat, but I just came out of it. It was a sudden meeting as such. I'm really sorry in case I have wasted your time. I know this is a weekend, very important for each one of you. Thank you. Thank you so much. Thank you. Thanks a lot. And before coming to tomorrow session, please install the NVIO software if you're coming, if you're going to practice along with me. I have already shared the link how to install the NVIO. I have also given the instructions. Please join with your laptop or PC if it's possible. Okay. Thank you so much. Thank you. Thank you. Thank you. Thank you, Professor. Thank you for subscription. Thank you. Data is not having problem, sir. If you are not installed the SPSS software, you can't open that data. Professor Marium, subscribe. Thank you. Due to technical issues with my laptop, had some problems with working with the data. Please check it out. If you are able to install the SPSS, you can open the data. Okay. So, any questions before ending the session?
Okay, so thank you so much, dear participants, for your beautiful participation and good cooperation. Successfully, we are completing our day. We are about to complete the course in 4 days. So, requesting you all to give your cooperation for the remaining 4 days also. And tomorrow session will be started by 6 and end by 8 o'clock. I will repeat, tomorrow session will start by 6